Hello everyone. Today's our topic is defining the exception timings in processing general exceptions. So here in finding the exception timings, we are going to find out the interrupt response time. So here already we defined the interrupt response time TD, which is equal to TB plus TC. So this is the interrupt response time. So here TD is interrupt response time, TB is interrupt latency time, and TC is the processing time. So nothing but here whenever any interrupt is going to be occurred, if the interrupt is sending to the interrupt service routine, and you can identify how you can process the interrupt, and by defining the different times of finding out the interrupt latency and finding out the processing time in order to process the interrupt. So for this purpose we are defining the interrupt response time. So here interrupt latency time, which is nothing but the time difference between whenever interrupt is going to be raised and after that interrupt is going to be sending to the interrupt service routine. So after it is sending to the interrupt service routine and it can be processed by the interrupt service routine. So likewise we are going to define the processing time till the completion of the interrupt. So for this purpose we are going to find out the interrupt response time here. So in this case, so one more is here. So how can you find out the different times between the raising of multiple types of interrupts here? So here in this case, whenever any normal kind of interrupt is going to be occurred, if any kind of high priority task is going to be executed, whether the interrupt is going to be processed or not. So that is the question here. So here in this case, you can observe the interrupt service routine in two contexts. First thing is, its main aim is to reduce the processing time. So nothing but each and every time you are going to observe the type of processing time in order within less span of time the interrupt is going to be processed. Why? Because so already we discussed that we can't entertain more number of interrupts, and we can't accept the device which is causing the more number of interrupts. Whenever interrupt is going to be observed each and every time, we are going to identify its priority. The second thing is observing the priority. So the interrupt service routine in the ISR context, it defines and it executes the exception timings in two ways. First one is its aim is reducing the processing time of interrupts, and second one is whenever any low priority interrupt is going to be executed, if the high priority interrupt came, automatically the high priority interrupt can preempt the low priority interrupt, and currently it can run the interrupt. So for this purpose, each and every time the temporarily it may be suspended and resumes its execution. So likewise we may execute saving the contents, loading the contents, restoring the contents. Likewise we are going to define each and everything. So here in this case we can observe, so whenever for the purpose of interrupt service routine context and for the purpose of task context. So nothing but generally normal execution of a task is going to be executed, then automatically any kind of error condition is going to be occurred, and this can be sent to the exception handler or this can be sent to the interrupt service routine. So if it is executed in the interrupt service routine, we are going to define how it can be processed in the interrupt service routine. So likewise we are going to identify here the interrupt service routine and the task interchangeably. So for this purpose of whenever interrupt service routine, the control is executed in the interrupt service routine, if any kind of high priority task is going to be executed, so automatically the high priority task can preempt the interrupt service routine interrupts. So here in this case we should define the total context in this diagram here. So here we can observe, so generally we define the interrupt response time with the scheduling delay and processing time. So here it can define the context with the help of interrupt service routine. Here TB is nothing but interrupt latency, and TC is nothing but processing time for the interrupt context, and TE is nothing but the scheduling delay, so which can be executed for the purpose of task, and the next one is TF, which is for the purpose of executing of the task context. So likewise we are going to define the TD here. TD is nothing but the interrupt response time. So here in this interrupt response time, so whenever the response time which includes the interrupt latency and processing time, and it adds the two more times of scheduling delay and processing time of a task, and automatically the interrupt response time will be increased when compared to TD equal to TB plus TC. So here in this case the interrupt response time will be increased only because of the two times. The first time which is going to be calling it as here TE scheduling delay and scheduling delay, TE, scheduling delay, and second one which you are going to be calling it as the processing time. So first we should see here, whenever any interrupt is going to be occurred, so here automatically the interrupt raised situation which we are going to be calling it as here interrupt latency means the time gap or the time difference between the interrupt and raising and the sending to the interrupt service routine, which we are going to be calling it as interrupt latency. The time here is called as TB. And second one which we are going to be calling it as TC. Now, whenever it is entered into the interrupt service routine, the processing time it takes to complete its execution, it needs the TC. So, whenever if it is currently running and automatically any kind of task is going to be occurred. So, here this task is high priority task. So, here in this example we are naming that task as Daemon Task. The Daemon Task is nothing but it is a background task which can be executed whenever a real time operating system means internally it runs Unix or Linux operating system. So, for this purpose the background programming is going to be executed. So, these background processes which are having the high priority. So, likewise we can define if it is in the Linux or Unix, if it is executing a shell program which we are going to be calling it as SHD. Whether if it is executing for the nested file system and automatically it is going to be calling it as it is NSD. And generally the real time operating systems which we are used it as a tiny OS and NS2 network simulators, NES-C programming languages. In all these cases internally it runs the background processes. So, whenever if the embedded systems architectures or designs which are executing in the network or communication network, automatically the internal running the Daemon Task which we are going to be calling it as with the protocol of HTTPD. So, likewise we should use the Daemon Task, and these tasks are the background tasks which can execute with high priority. So, whenever this high priority task is currently executing, then automatically the currently executed interrupt is going to be suspended. So, nothing but here the task can suspend the interrupt, currently executing interrupt in the interrupt service routine. So, here it is suspended. Then next thing is here the task gets starts. So, with the scheduling delay. So, nothing but here the scheduling delay time which we are going to be calling it as TE. Nothing but scheduling delay occurs whenever the high priority task is ready to run or whether it is in the running state. Then the scheduling delay occurs. So, nothing but it is moving from the ready queue to running queue. Nothing but there is a switching the task which is waiting in the ready queue, high priority task. Whenever this interrupt is going to be suspended temporarily, then immediately the task which can move from the ready queue to running queue. So, the time gap between the ready queue moving running from ready queue to running queue which we are going to be defined it as T, the scheduling delay. Then after that the processing time, TF is nothing but the processing time within the task context. The task is ready to execute and after completion of and it is running here, the task is running here, and after the completion of the task then wherever the interrupt is suspended and it restores and it begins its execution. So, likewise here we should define the interrupt response time by increasing the delay, scheduling delay and processing time for this purpose. So, here in this case every time we are going to observe whenever in the embedded system architecture and any embedded system design, we are going to reduce the multiple number of interrupts here. So, here for effective implementation of this one some amount of memory is going to be allocated. So, with the help of C programming language. So, here it is going to be calling it as malloc. So, by using the malloc function we are going to reserve some amount of memory space to processing of these interrupts as well as the contexts. So, likewise we are going to process the exception timings. And next one we are moving to the next concept called nature of spurious interrupts. And the next thing is going to be calling it as here spurious interrupts. So, whenever the spurious interrupts are going to be occurred here. So, these spurious interrupts are occurred generally whenever any interrupt is going to be occurred, then it is handled in the interrupt service routine section. So, in this interrupt service routine, so during the execution of these instructions in the interrupt service routine, so if any problem is going to be occurred, or it can detect any kind of error conditions, unknown error conditions, so automatically it leads to the critical system. So, for proper execution of this interrupt service routine, then in order to raise the interrupt service routine instructions and properly execute the instructions in the interrupt service routine, it should define some kind of signals. it can generate some kind of signals. So nothing but when any error conditions are occurred in a critical system, in order to bring the system into safety system method, then some signals are going to be generated, and these signals are going to be generated for very short duration of time. So the spurious interrupts are the very short duration signals which are generated in the normal execution of the interrupt vectors or interrupt lines. So these type of interrupts are called as here spurious interrupts. So when any interrupt request is going to be came from the interrupt service routine. So IRQ is nothing but here interrupt request, ISR is nothing but here interrupt service routine. So when any request is going to be came from the interrupt to bring the system into safety state by indicating some kind of error conditions. So these error conditions are going to be detected by generating some kind of signals. Nothing but these are nothing but here generating or issuing some kind of alert signals or warning signals. So if any problem is going to be occurred in a, for example, if a central locking system is going to be occurred, if any kind of fire or theft are going to be occurred, automatically it is going to give some kind of signals. So nothing but these signals are generated as warning bells. Then automatically the system can be detected that the system is in the problem. So likewise we are going to identify and to bring the critical system into the safety method. Then you are going to generate some kind of signals, and these signals are going to be generated with the help of sensors or transducer. So in embedded system architecture, we are going to issue some kind of signals through with the help of sensors or transducers. So these signals are two types. So the first signal which we are going to be calling it as here a digital signal, and second type of signal which we are going to be calling it as here analog signals. So only at the time of detecting any kind of unknown errors during the execution of interrupts in the interrupt service routine, to identify that error conditions, these are defined it as some kind of alert signals or warning signals with the help of sensors. So it can alert the total system. So for this purpose, in the signals which are generated is in the form of digital signals and analog signals. Both the combination of digital and analog signals which we are going to be calling it as here real-time signals. So in the real-time operating system, the real-time signals which are generated are digital signals and analog signals. So these signals in the real time, in the real world situation, whatever the concept we are discussed, that should be somewhat different in the real-time operating system. So here in this case the digital signals which are generated, so in this case the digital signals which are observed for edge triggering. So nothing but these signals are going to be generated when any kind of event or condition is going to be occurred. So nothing but some any kind of error condition, or it may be defined it as a trigger, some action is going to be executed here. So in this case during that event point or triggering point in a particular amount of time, if any kind of a problem is going to be occurred from an interrupt, then automatically a request is going to become, interrupt request is going to become in that particular event or in that particular error condition or triggering point. So we are going to generate some signals, which signals called as here digital signals, and these digital signals here in this case some moment of time, some action period of time, it may rise, it may grow, and it may fall down. So likewise the signals may be increased or the signals may be generated which are maybe fall down. So likewise so nothing but it indicates the rising or falling edge. So likewise we should define the edge triggering conditions. So these edge triggerings purely they can generate the signals to the sensors. Those are going to be calling it as here digital signals. And second one which we are going to be calling it as here analog signals. The second type is going to be called it as analog signals. These analog signals which can be generated if any kind of request is going to be came during any kind of problem is going to be occurred, then interrupt request is going to be came, automatically they can increase the signals per a particular moment of threshold value. If we are going to specify some boundary value, then if it is reaches more than its marginal value, then here it indicates the analog signals. So this type of triggering which we are going to be calling it as here level triggering. So likewise we should specify the very short duration of interrupts. So nothing but these signals are going to be occurred during the execution of the interrupts. Here, during the execution of interrupt signals, some very short duration of signals are going to be generated, and these are emergency signals which should be used in a critical section in order to make the system safety. Likewise, we are going to use the alert signals is in the form of digital and analog signals, which are called as real time signals. And here in this case, we should observe the two things here. Both the digital signals and analog signals here, the combination of these two signals can be generated with the help of real signals. So here each and every time we are going to specify the threshold value based upon this. So both the digital signals and analog signals here which we are going to be used, so in the form of programmable interrupt controller or microcontroller. So whenever coming to the embedded system design or any kind of embedded system, we should need to run this level triggering and to run this edge triggering. So we should need the programmable interrupt controller. Then automatically it should moving from whether they are low or whether they are high, whether they are medium or whether they are highest. Based upon this, the programmable interrupt controller can execute each and everything. So likewise, purely we can use microcontrollers are also. So here whether in the case of the sensors which are generating the digital signals or analog signals, which needs filtering and which needs debouncing mechanism. So here the debouncing mechanism is nothing but it is a process of removing the bounces, nothing but converting the real time embedded systems into the safety system, nothing but any kind of a problem is going to be occurred and automatically it is going to run the critical section code. Likewise, it is going to make the system into safety mode. So likewise, we may execute the edge triggering mechanisms and level triggering mechanisms in the form of both digital signals and analog signals. So here in this case, the spurious interrupts are nothing but here these are generated for very short duration of interrupts. These very short duration of interrupts which are generated in the normal interrupts which are going to be executed in the interrupt lines. So for this purpose, we are going to define according to the request of the interrupts. We should define the total real-time embedded system in the form of generating edge triggering and level triggering mechanisms. Hope you understood. Thank you.